Okay, hello Year 13s. We're going to go through Environmental Systems and Societies, Paper 1, and just see what my thinking process is as I go through this. So we scroll down here. State one type of solid domestic waste management strategy. Now, unfortunately, today I don't have my pen on my computer, so I just have to type here. But instantly I'm thinking about strategies that I'm going to use. What am I going to do with my waste? I'm going to throw it away. Okay, so a bin is a waste management strategy, but what happens to it after that? Okay, so I can recycle it, okay, which is very popular in the United States. I could incinerate it, and I could, if I do that at a high power or high temperature, using good infrastructure, good factory, then I can even generate power from it. Okay, I can do landfill, and that's probably enough to be thinking about for now until I look on to the next question, and then an advantage and a disadvantage. Well, I mean, incineration, it's expensive. Landfill, inexpensive, and I don't really know an advantage for landfill. Recycling, I suppose the advantage is that you're not using the original resource, and a disadvantage is it still takes energy. Okay, so I'm going to go with recycle. So I actually looked at the second question before the first one. So 1A to recycle. And that's all I'm going to put. It's just one mark, and then 1A part 2 advantage. We can reuse the materials in another form rather than using raw materials from the earth, such as fossil fuels. And disadvantage is that it still requires energy, which is usually going to be fossil fuel energy, to convert recycled, to convert waste into recycled okay. Alright, so there's probably, because it's not usually, so one question isn't usually going to be just two parts, and you can see it's A over here, so there's probably going to be a B now. That's what I'm thinking. Okay, so we've got some more now on solid domestic waste, probably asking a slightly different thing. We've got a table here talking about Australia over the period of 1 year, different types of waste, different amounts of it, proportion of total mass, what percentage of the total's down here. So now they want me to calculate the proportion of paper and food. Now notice it's and, so let's do paper first. Paper is 396 plus food is 648. I think I can get OneNote to do this. Nope. So that is 14, 13, 14, and 10. So 1044 is the total divided by 1800. Okay. So I'll just snip over to my calculator here. So 1044 divided by 1800, looking at 0.58, and for a percentage that's going to be 58%. Enter these two values into the table above. Oh, I misunderstood this question. Okay, just so you know, I'm doing this actually live. When it said and, I thought they were combining. It's not until I finished reading this part that I realized they want me to do them separately. So that's why I should read the question completely. Okay, so now I'm going to do it again. It's 396 out of 1800 to do the paper. So going back to my calculator. 396 divided by 1800, 22%. So I can put that over here. And then the other one, calculator down here. Is 648 divided by 1800. Okay, and I'm already thinking about the fact that they're probably going to ask me to do some kind of interpretation of this, is what I would guess. Is what's coming next, so this 36%. Okay, complete the following bar chart using the data calculated in B1. Okay, so paper, now it says label the chart correctly, so that means they want me to label my axes. So here, this axis has got to match what's on my table, proportion of total mass. And do it as a percentage. Okay, so that's that axis there. And then this one's got to match the other table, so this is waste type. Okay, back. All right, and then I would plot my paper in here. Right, so that's 22%, so it's going to be up here somewhere. And then food waste, 36%. And so, I mean, with a bar chart, you can instantly see then that the paper and the food waste are the most, and food waste is the most. Just makes it really, really clear to see. But notice that it says label the chart correctly. That's probably going to be for a whole mark here. Right. Now we're still on question 1. Define the term carrying capacity. I mean, I can define that, but I'm also still thinking about waste, and I'm thinking about how, you know, there's probably not enough resources for the whole world, and that might help me remember what carrying capacity is all about, right? So carrying capacity, the number of individuals in a species that an environment can support. If I had lots of time, you know, in this case, the number of people the Earth can support given its limited resources, something along those lines, okay? So now they're extending this. Why is it difficult to measure carrying capacity for a human population? Well, first of all, we don't know how many resources are remaining, and therefore how many people the Earth could support. And I'm sort of linking that now to agriculture and the Green Revolution. And so when the Green Revolution came along, it changed a lot of things, and suddenly the Earth could support so many more people. We wouldn't have predicted that. So new technologies can change the carrying capacity by increasing productivity or increasing the lifespan of a resource. And there was something else I was thinking. Oh, well, we just don't know really the psychology of humans. For example, some countries have started to become less consumer driven, e.g. Like the Netherlands, okay, very conservative. Most people ride bicycles, you know, people are very environmentally conscious. Some countries don't use as many resources, so it becomes really hard to predict what the future holds. Okay, so maybe we can have many more people on the planet, but everybody using less resources, it's hard to know. Okay, and I'm going to stop there for this one.